Hey everyone, and welcome. So in Java, you sometimes hit this really specific problem. You've got some setup code and it absolutely has to run exactly once. No more, no less. Today, we're going to dive into a super powerful, specialized tool that Java gives us for exactly this job, the static block.
All right, let's just jump right in with a puzzle. Imagine you have a piece of code, maybe it's some critical initialization, and it has to run one single time for an entire class. It doesn't matter if you make one object, 10, or even 100 from that class. How would you actually pull that off?
Well, to answer that, let's do a super quick refresher. Remember the difference between instance and static variables? Instance variables, like brand or price, they belong to each individual object. Every new car gets its own unique price tag. But a static variable, say a company name, that's shared. There's only one copy for the entire class, and every single object shares that one copy.
Okay, so if you want to set up that shared static variable, your first instinct might be, hey, I'll just put it in the constructor, right? It's right there with the other variables. Seems logical, but yeah, there's a pretty big problem with this approach.
And here's the catch. The constructor runs every single time a new object gets created. So if you make 3 objects, guess what? You're reinitializing that shared static variable 3 times. It's not just a little inefficient, it completely defeats the whole point of a one-time setup. We need a better way.
And that better way, you've probably guessed it, is the static block. This is the specialized tool that Java gives us for exactly this kind of one-time class-level setup.
So what is this thing, really? Well, a static block is just a special chunk of code inside a class that is absolutely guaranteed to run only once. And here's the most important part. It runs when the class itself is first loaded into memory.
And the syntax? It could not be simpler. It's literally just the keyword static, followed by a pair of curly braces. You just drop whatever one-time setup code you need right inside. That's it. No method name, no return type, just static and your block of code.
Okay, so to really hammer this home, let's put the static block and the constructor head-to-head. We'll watch them execute and see exactly what happens.
All right, let's run a little experiment. I've got a simple class here. It has a static block that prints in static block and a constructor that prints in constructor. Now, in our main method, we're going to create 2 separate objects from this class. Let's see what the terminal tells us.
And boom, there it is. Look closely at this. In static block is printed only once, and critically it's printed first. Then, in constructor prints twice, once for each object recreated. This is the aha moment. It perfectly shows the core difference. The static block runs one time when the class is loaded, way before any objects are even created.
This table really just sums it all up perfectly. For purpose, a static block is for that one-time class setup. A constructor? That's for setting up each new object you create. For execution count, it's once per class for the static block, once per object for the constructor. And the timing, this is key. The static block always runs before any constructor.
So this brings up a deeper question, right? It's not just some random rule that Java follows. There has to be a fundamental reason why the static block always gets to go first. So what's really happening under the hood?
To get that why, we need to take a little peek inside the Java Virtual Machine, the JVM, and see how it actually handles our code.
Okay, here's the secret. Creating an object in Java is really a 2-step process. First, the JVM has to find and load the class's definition into memory. We call this class loading. Only after that's done can the JVM start creating individual objects from it, which we call object instantiation. And the most important thing to get here is that step 1, class loading, only ever happens once for any class.
Here's a great way to think about it. Class loading is like an architect unrolling the master blueprint for a building. That happens just one time. The static block runs during this unrolling the blueprint phase. Then, object instantiation is like a construction crew using that blueprint to build an actual house. This can happen over and over, and the constructor is the code that runs for each and every house that gets built.
This leads to a really interesting thought experiment. If the static block runs when the blueprint is unrolled, what happens if we never tell the construction crew to build a house? What if we create 0 objects?
Let's test it out. So here's our same class, but this time notice we've commented out the lines that create the objects. We are not making any instances at all. Based on that blueprint analogy, what do you think is going to happen?
Absolutely nothing. The output is totally blank, and this proves our analogy perfectly.
If you never ask to build a house, the architect doesn't even bother to unroll the blueprint. The JVM doesn't load the class, which means the static block is never even triggered.
But what if you wanted to unroll the blueprint without actually building a house? Well, Java gives us a way to do that. There's this special method called class.forName that lets you explicitly tell the JVM, hey, go load this class into memory for me right now, even if you aren't creating an object from it.
And this really brings it all home. Check this out. We run our code one last time. No objects are being created. We are only calling class.forName. And what's the output? InStaticBlock. This is the definitive proof. The static block is tied directly to the act of class loading, totally separate from creating objects.
Okay, let's wrap this all up and just quickly go over the key things to remember from all of this.
So, if you only remember a few things, make it these. First, the static block is your #1 tool for one-time initialization of static variables. Second, it runs automatically when the class gets loaded by the JVM for the very first time. And third, because of that timing, it will always run before any constructor for that class is ever called.
And that leaves us with one final thought. Now that you really get the when and the why of static blocks, think bigger than just setting a variable. What other complex one-time setup tasks could this be perfect for? Things like maybe loading a database driver or reading a critical configuration file just once. The possibilities are pretty cool. Thanks for tuning in.